the minimum velocity in meter per second with which a car driver must traverse a flat curve of radius 150 meters and coefficient of friction 0.6 to avoid skidding is to be calculated. So when the car, let us say here is a car, which is the top view, it is heading forward but it is turning to the left, which means its velocity vector is forward but its acceleration vector would be sideways. And this acceleration is a centripetal acceleration. What is the maximum centripetal acceleration that can be provided? It would be equal to the frictional force between the tires and the road. So we have F max is equal to the force of friction mu into the normal reaction mg. And what is the actual force? The centripetal force is equal to mv square divided by r, where v is the velocity of the car and r is the radius of the turn. Therefore, mv square divided by r must be less than mu mg. M can cancel out here, so we have v square less than mu gr. So v is less than the square root of mu is 0.6, g can be taken to be approximately 10, and radius is 150 meters. Therefore, velocity must be less than the square root of 6 into 150, which is 900, or velocity must be less than 30 meter per second. So we have the maximum velocity to be equal to 30 meter per second. The minimum velocity is asked in the question, but that is likely a typo since there is no limit on the minimum velocity. So we can go with option B to be our answer.